what we're going to talk about here at the top, we haven't talked about this yet, it's called a relative maximum and a relative minimum, which you're going to see on a couple of these graphs. So the first graph I have is an odd. That should be a minimum of a third degree, if you remember from yesterday. It's got a negative leading coefficient because it goes down to the right. But what I want to show you here is what we call relative maximum, relative minimum. So it just has the definition for you at the top. It says the greatest value of the points in a region of the graph, and specifically it's going to be the y value of that point. So it's not going to be the x value, it's just going to be the y value of that point. So if you look how this graph goes, like one side goes up to positive infinity, one side goes down to negative infinity, but in between here, we also call these a turning point. And when you have a turning point, you can have a relative maximum. So just if I looked in this little region of the graph, this is the relative maximum. Even though this side goes up to positive infinity, there's a relative maximum there. And then a turning point where it goes from decreasing to increasing. We have a relative minimum here, but we don't have what we call an absolute minimum because that goes to negative infinity on that side. So if you have an odd function or an odd degree, you probably will have a relative maximum and a relative minimum. I don't want to say always, but you probably will. Now, if you have an even, which is what I have over here, this would be a fourth degree negative leading coefficient, both ends point down here. Now, this has something else, which the definitions are under here. Absolute maximum and absolute minimum. You can't have both on the same graph. And it says here the greatest y value of the entire graph, and it's not, it says it doesn't exist if the end behavior, and I'm going to put, goes up, up. You will not have an absolute maximum if both ends go up. This graph that I have pictured does have an absolute maximum. So this is absolutely the top of the graph because both ends point down. See that little point I kind of highlighted in green? This also has a relative maximum and minimum over here. The relative maximum you see is a little bit lower than the absolute maximum. So you can have both of those on the same graph. And then I have a relative minimum here, kind of this turning point. But I don't have an absolute minimum because that goes down to negative infinity. So this one says absolute minimum, the least value of y on the entire graph, and it's not going to exist if your end behavior goes, both ends go down. These only absolute max and min are only going to exist if you have an even degree. If you have, and that's what this says here, absolute max and min don't exist for odd degree polynomials because one side goes up to positive infinity, the other side goes down to negative infinity for an odd. So these absolute maximum or minimum can only exist if you have an even degree polynomial. Okay, so I just have a couple little sketches here of some different graphs. So I just want to kind of point out to you where you would find what. So on this first little graph here, just where the graph, it's called a turning point, like I said, where it switches from decreasing to increasing or increasing to decreasing. That's where you could see your relative max or min. This one is kind of at the top. So on that graph, that would be a relative maximum. I don't have specific points really listed there. I don't know what the scale is or anything like that, but just to kind of point that out. And then like this point down here would be a relative minimum on that graph. No absolute max or min at all on that graph. Now, this guy's a parabola. You only have one turning point right here. That's not a relative maximum. This would be an absolute maximum because that's absolutely the top of the graph. There is nothing above that point. So it's possible that you just have, like that one just has an absolute maximum. It doesn't have a relative maximum. And then the last one here, this all the way down at the bottom, that would be the absolute bottom of the graph. This would be an absolute minimum. And I know this is super tiny in here, but these two little turning points kind of up in here, try and draw a little arrow. This one where it bumps up, this is a relative maximum. And this one where it kind of dips down, that would be a relative minimum. So what we're going to work on today, we're just going to talk about some different types of things we can use to analyze the graphs here at the bottom, but I'm going to ask you if you have relative maximum, minimum, absolute maximum, or minimum. Some of the questions, when you answer them, we won't have one, and that's okay. So we're going to go through a couple examples here on the bottom and the back of the notes. Okay, now, just total throwback. So I'm going to ask you for domain and range here. So here's the graph, and I have some points that are kind of, I stole this from Desmos, but the points, kind of the important points on the graph are identified for you with right next to where they're at. So just a quick question, domain, remember, we're going to go from left to right. What would you tell me the domain is here? We'll just use our interval notation. What would you tell me the domain is? What are all your possible x values? What do you think? Heck yeah. I know it's going down and that's going up, but this is going to the left forever. This side's going to the right forever. So any odd degree polynomial, any one of them, any odd degree, the domain should be negative infinity to infinity. All right, for the range, remember that's describing the y values, and you want to go from the bottom of the graph to the top to describe the interval to me. What would you write for the range here? Like going up and down. What are my possible y values? Yeah. It's the same. Yeah, this side goes down forever, this side goes up forever, so you cover the whole y-axis. So any odd degree, I promise, they will all have the same domain and range, and it should cover all the x's and all the y's. That's not true for even degrees, which we're going to look at one of those on the back. All right, now, all you would have to do to list the zeros, and I've got the points like right on the graph. Don't list the actual point, but just go ahead and list, like, we have -5, -2, and 3. Where would I look to find the y-intercept for the graph? Do you guys know where that's at? Or what would it be? Gabe, what do you think? Yes, okay, that's where it crosses the y-axis. So 0 should be the x-coordinate. This one ends up with a nice point that's -30. Okay, now, this graph is odd. So one end goes down forever, one end goes up forever. We'll cover the whole y-axis. So I'm going to ask you about these absolute max and min, relative max and min. This graph, if it's odd, you just automatically don't have an absolute, because one side goes to positive infinity, one side goes to negative infinity. So you won't have like a stopping point where you don't have any graph above or any graph below. Now, the relative max or min, this graph has both of those, and I just need the y value for that. So where do I have a relative maximum? Like what number would you tell me is a relative maximum on this graph? Just raise your hand and tell me which y value on that graph is going to be my relative maximum. What do you think? Yes, okay, now you're on the right point. So this is going to be my relative maximum. Now, when you write it, what you do is you write down the y value. So I'm going to write that 14.815. That's the y value. Okay. Now, what you can do, and they do this in the pre-calc and trig, and they say that that occurs at the x value of, so I'm going to say at x equals -3.667. Sorry, we got a lot of decimals on some of these points on the graph today, but that's what we would say for the relative max. The actual max is be that 14.815, and it occurs at the x value of -3.667. Okay, where would I have my relative minimum on this graph? Because it also has a relative minimum. It's asleep, tell me. Exactly, good, right there. That's your relative minimum. So you would just, this one's actually a nice number. So -36 at x equals 1. So the relative maximum or minimum, or absolute maximum or minimum, if either one of those, you describe that with the y value, and then you can say at x equals whatever the x coordinate of that point is. Is anybody having a question? Okay, now, it has been a long minute since we have done this, but we're going to write down intervals of increasing and decreasing on this graph. And I'm going to grab two different colors here. when you have a polynomial, it can have more intervals of increasing and decreasing the higher the degree. So like we did this with quadratics, and there would only be a couple of intervals, one for each really. So this is going to include more intervals. So intervals of increasing is where I am going from left to right. I'm just going to trace right on the graph. Where are my y values increasing? So if I'm tracing, like this whole time I am increasing until I get to that, actually that relative maximum, that's that turning point. Then when I get to that point, this little piece of the graph, the y values are decreasing, decreasing, decreasing as I'm tracing this. And then I get to that relative minimum, and then I am increasing, increasing, increasing for the rest of the graph. Okay, if this helps you in any way when you do these have to be described across the domain. So we should be using x values for increasing and decreasing. Okay, so I just have the one interval, or no, I have two intervals where I'm increasing. So the two that I colored in green. So all the way here to the left would be to negative infinity, all the way to the right would be positive infinity. All right, so I'm going to start, I'm increasing right away as I'm tracing this. So from negative infinity until I get to that turning point. Now the value you want there is the x value, which is that negative 3.667. Sorry, so like I said, some of these numbers are a little bit longer, but we'll just write that out. And both of those have parentheses. You always have a parenthesis around an infinity symbol because it's not touching an actual point. And the reason I don't have a bracket here is because I am not increasing or decreasing at that point where I switch direction. We are just kind of flat there, so that also has a parenthesis. Okay, then at that same point, I'm just going to come here, that same x value, that's my turning point. So I turn, and then I'm going to decrease. So that 3.667, I'm going to use that again. And I'm decreasing for this whole little piece until I get here at my other turning point. And the x value there is 1. So from negative 3.67, I'm going from left to right as I trace. At 1, I'm going to turn direction. So then I'm going to put a little union symbol on my intervals of increasing. The rest of the graph is increasing. That starts up at the x value of 1. And for the rest of the graph, which would go to positive infinity, then your y values are increasing. Is anybody having a question? I'm going to try one more with you, and then I'm going to have you guys look at a graph on Desmos. Okay. Now, this one is even. What would you tell me for your domain for this graph? This is an even degree. What would the possible x values here be? What do you think? It's a quick today. What do we think? Like left and right, what are my possible x values here? Heck yeah, that goes left forever, that goes right forever. It goes up really quick, but it does cover, it would spread out across the whole x-axis if we had a bigger picture. Now, what would you tell me for the range? Like we want to go from the bottom of the graph to the top to describe the range. What would you tell me for the range for this graph? What do you think? Yes, perfect. Okay, now I'm going to use a bracket on this. Like the first point I touch would be this point right down here. And sorry, I need to find one with less decimals, but this is negative 45.335. That would have a bracket because we actually touch that point, and then the rest of the graph just points up forever. So that would go up to infinity. And so I'm going to have a parenthesis there. All right, now the zeros, we can list these really quickly. So we cross the x-axis or touch the x-axis at -2, 0, and 4. This is really tricky. What is the y-intercept for this graph? It's the origin. Yeah, it's 0, 0 here. Okay, now this is going to be very tricky. Let me start with the absolute max and min. Do I have an absolute maximum on this graph? No. If the two ends go up to infinity, that does not go to a specific point, so it does not have an absolute maximum. Do I have an absolute minimum for this graph? Yes, and if you've done the range right, the absolute max or min for an even degree polynomial should match whatever the y value is in the range. So this is absolutely the bottom of the graph, that negative 45.335, and I'm going to put that occurs at the x value of 2.88. Oh, sorry, I forgot to put x equals. At x equals 2.886. Okay, now, does anybody know what the relative maximum is? There is one on this graph. What is the relative maximum? So it has to occur at a turning point. So it has to occur like a curve, almost like a vertex. What do you think, Gabe? Yes. Okay. So I know this is weird, but this would be your relative maximum right here. Just a little bump up. So I'm going to have to write 0, but I have to write at x equals 0. We just want the y coordinate of the point. Can anybody, I have an absolute minimum, right? That was all the way down here. This, right, this negative 45.335. So that's the absolute minimum. What number is going to be my relative minimum? Yes, this one right here. All right. Oh, sorry, I should have given you guys a little more space. So this would be the y coordinate always for these, 6.353, and I'm going to say that occurs at the x value, negative 1.386. Okay, now I'm going to trace this again for increasing and decreasing. You don't have to do this, but you want to go from left to right. And let me do the same thing I did on the front. So I did decreasing in purple. So when I start the graph out, going from left to right, all my y values are decreasing till I get to that turning point. That's going to be my relative minimum. And then there I turn and I'm increasing for just a short time. And then I get to the relative maximum at another turning point. And then I'm going to be decreasing, decreasing, decreasing until I get to that absolute minimum for the graph. And then the rest of this goes up forever. So the rest of that would be increasing. So I should have 2 intervals that I described that are decreasing and 2 intervals I described that are increasing. So don't forget, for these increasing and decreasing, you have to use x values because you're describing a portion of the domain. Okay, so all the way to the left forever would be negative infinity. All the way to the right forever would be positive infinity. So my first little interval, this little one I colored in purple, all the way to the left forever, that'd be negative infinity. I'm going to come down, scooch this a little bit. Can I get that on? Oh my gosh, I didn't space this out well. Should be from negative infinity, I am decreasing until I get to that turning point. Want the x value there should be that negative 1.386. Okay, now at that same x value, that negative 1.386, then I start increasing just for a little tiny bit, just till I get to the x value of 0. And then at 0, then we start decreasing again. So then I'm going to come, sorry guys, I spaced this out horribly. So I'm going to put a little union symbol, just means there's 2 different intervals where I'm decreasing. So 0, and then don't write the y value, it's the x value. So I'm all my y values are decreasing until I get to the x value of that 2.886. And then at that 2.886, then we turn and we start increasing again. So then the rest of the graph, from 2.886 to positive infinity, the rest of the graph is increasing. Does anybody have a question? Now, I'm going to have you guys, if you want to get your laptops out real quick, I'm just going to have you guys do these 2 questions on Desmos super quick. And we're just going to talk about relative maximum and minimum and find the zeros. Relative maximum, minimum, and we're going to find the zeros. Promise it's not going to be hard. I'm going to pull my... So it's just desmos.com if you don't have that bookmarked. And if you go to the screen and you don't have it bookmarked, I'm just going to delete this. If you go to this screen, oh, this looks different than one. What in the world? They totally change this. Oh, just click on the graphing calculator if it takes you to that screen. That's what we want to do. I just have the graphing calculator bookmarked on mine. Okay, now, I'm literally just going to type this equation. So I'm going to type y equals x to the third. And remember, if you want an exponent, just hit that shift 6. That'll take you into an exponent. Little caret button. I'm going to arrow out of the exponent. I'm going to put plus 4x squared. And then I'm going to write minus 5x. Okay, see if I can display. Now, you can literally grab the graph with your fingers if you want to alter it. So I like just kind of grab the y-axis and I can scrunch it down, and I can kind of grab the x-axis and move it. So you should be able to just manipulate that with your fingers. And if I'm looking for relative maximum and minimum, so I'm just going to write down the zeros right from the paper here. If you remember, you can literally click on this and it will go to critical points. If you click on the point, it'll hold it on the screen for you. So I'm just kind of clicking on all these points here. The zeros should just be where the graph crosses or touches the x-axis. So I've got -5, let's see, 0 and 1 for this graph. And then it asks you to state the relative maximum and minimum. So I have both of these for this graph. It doesn't have an absolute max or min because one side goes to positive infinity, one side goes to negative infinity. But my relative maximum, and I'm just going to write down the decimal place. Okay, so it's the y value, should be that 24.193, and I'm going to say that occurs at the x value 3.189. That's all you have to do. Relative minimum, just look on your graph, it should be this way. It's at a turning point, kind of like the bottom of a parabola. Relative maximum would be kind of like at the top of an upside down parabola, so it's got to be a turning point. So on this graph, it's going to be, right, relative min, and we've got, what is this, negative 1.378, and that happens at the x value of 0.523. That's all you have to do. Does anybody have a question? Okay, I'm going to scooch this graph to the other side real quick so I can type this equation in. Maybe I'm going to type this equation in. I'll just slide you. Alright, so this one I've got negative x cubed, so you can just use a little negative key in front of that. And then it's plus 16x squared minus 76x, and then plus 96. And again, if you want to hide the equation so you can see the graph better, just hit those two little sideways arrows at the top, and that'll move that out of your way. I'm just checking real quick to make sure I typed that correctly. And I should probably have a y in front of that. Okay. And then again, if you want to move it around with your finger, shift it, however, I usually just grab like the x-axis or the y-axis to kind of stretch it out just so you can see it. But really the critical points I'm looking for here, my relative maximum and then my zeros. So my zeros all end up looking pretty nice here. So just jotting those down. Let's see, we've got 2, 6, and 8. And then this has a relative max and a relative min both. So the maximum, again, it's kind of like the top of an upside down parabola. So it's going to be a turning point. This is going to be a relative max. The relative min should be the bottom of like a right side up parabola, sorry, almost like a vertex. So you're looking for the y coordinate. So I wrote down max first. So what do we got? 5.049. And that's at the x-coordinate 7.097. And then my minimum, I can't spell, is going to be that bottom, so negative 16.901 at x equals 3.569. Does anybody have a question?